Hey there and welcome. Today we are going to learn how to solve systems of inequalities. Let's go ahead and get started. Alright, the first thing that we need to recall are our inequality rules. So we need to remember that inequalities have infinitely many answers, and we also need to remember all of the symbols for them. So remember, if the point is included in our answer, it's going to be less than or equal to, or greater than or equal to. It's going to be a closed circle, and it's going to be brackets. I'm going to add on to this that it's also going to have a solid line. And this part's new, and it'll make sense momentarily. If it's not included, those are our less thans and greater thans. They are open circles, our parentheses, and dotted lines. Again, the line part is new. We're going to talk about that in today's lesson, but it's important information to know. So let's look at this problem here. We have y is less than negative 1/2 x plus 6. And we know how to graph y equals negative 1/2 x plus 6, but this inequality is throwing us off. In reality, we're still going to graph it the same way. So we're still going to graph our beginning point first, which is at 0, 6. So right there. And then our negative 1/2 slope. And again, just like last time, we need to go across the entire problem. So because my slope is negative, I'm going to go down 1 and to the left 2, and then up 1 and to the right 2. But now, we need to figure out what kind of line this is. If you remember earlier, we said that if it's not included, it's going to be a dotted line or a dashed line. That tells me that the points on this line are not actually part of the answer, but it's the closest that we can get. But we also need to remember that inequalities have infinitely many answers, so we need to figure out where these answers actually exist. And the easiest way to do it is to pick a point on one side of the line. My personal favorite point to pick every single time is 0, 0, unless 0, 0 is on the line. If it's a proportional relationship, we can't use 0, 0. But so I'm actually going to plug that in. So 0 is less than 1/2 times 0 plus 6. I end up with 0 is less than 6, which is a true statement. This means that on the part of my graph where I put my dot to test, all of those points are going to be true. So I'm going to shade my graph below the line. And this shading is how we represent all of the possible answers. Any point that you use underneath the line is going to work and is going to be valid. So let's look at another one. All right, this time we have an actual system of equations. So y is greater than 3/2 x minus 5, and y is less than negative x minus 2. Let's start by graphing that first one. Y is greater than 3/2 x minus 5. My beginning point is at 0, 5. And my slope is 3 over 2. So I'm going to rise 3, run 2. Go both ways. And I have a dotted line. All right, again, I need to figure out where this point actually, which part of this line it actually exists on, which side. So I'm going to make my test point, again, 0, 0. So 0 is greater than 3/2 times 0 minus 5. So I got that 0 is greater than negative 5, which is a true statement, which means that I'm going to shade on the side of the line where that test point is. So over here. All right, so that was the first point. Now we need to check out that second line. So y is less than negative x minus 2. So my beginning point for this one is at negative 2, 0. And my slope is negative 1. So I'm going to go down 1, right 1. And I'm going to go the exact opposite and go up 1 and left 1. And again, this one is not included. It's just less than, so dotted line. Again, I need to figure out which side of the line the values of this are true. So I'm going to test my point of 0, 0. I can use the same test point because it's not on the line. So I'm going to say 0 is less than negative 0 minus 2. All right, and this time we said that 0 is less than negative 2, which is not true. which means that this time, instead of shading on the same side where our test point was, we need to shade on the opposite side. And it's going to look like this. Now, our final actual answer is going to be the point where both of the shadings overlap each other. So this orange portion here, where both of the highlighting parts cross each other, that is where our solution is. And when we have inequalities, this is really just how we represent it. The easiest way to do it is on a graph visually. All right, let's look at another one. All right, so this time we have that x is less than or equal to -3, and 5x plus 3y is greater than -9. So first let's graph that x is less than or equal to -3. We want that point where our x value is at -3 and all of the points where x are -3. I have no y in here, so there is no defined slope. That means it's going to be a vertical line. And because this one is or equal to, it's a solid line. So it looks just like this. Now we still have to pick that test point. Again, 0, 0 is my jam. But I only have to check the x portion of it. So 0 is less than or equal to -3. 0 is not less than or equal to -3. So that's wrong, which means I'm going to shade on the opposite side. All of the values this way, right? This is not where my test point is. Since I didn't get a true statement, my test point's wrong. All right, so now I have 5x plus 3y is greater than -9. And that's in standard form, so we need to change that to slope-intercept form. And now that I have my slope-intercept form for this equation, I'm going to start my beginning point at 0, -3. And I'm going to go down 5 and to the right 3. And then up 5 and left 3. This one is going to have a dotted line. And now I'm going to do my test point again at 0, 0. And when we check this one, we can actually plug it into either one of our equations, our standard form or the slope-intercept. I'll show you both. So when we plug it into the standard form, x is 0, y is 0, we get that 0 is greater than -9, which is true. If we plug it into our slope-intercept form, we have that 0 is greater than -5/3 times 0 minus 3. We get that 0 is bigger than -3, which is also true. So we're going to shade on the side of our line where that 0, 0 point actually exists. And so, again, our actual solution is the point where both of those highlighted sections cross over each other, which happens to be that skinny section right up in there. All right, and that's going to do it for us today. So we've now figured out how to solve a system of inequalities. Until next time, I'll see you later. Love you, bye.